Hey, good morning everybody. Alright, I'm back to the second part of the video. So yesterday I had to stop the video abruptly because my Apple Pencil ran out of battery. And so here we go, the second part of the video. So I just want to show you a question where the calculator is probably not going to be very effective because we are only given 2 points on the graph. And we know that if we want to use the regression function on the calculator, we need 3 points at least, okay? So we have to find another way to solve this question. But I would suggest to sketch the graph for this one. So we have a point which is -1, 9, which is somewhere about here. 0, -9, maybe somewhere about here. And we have x equal to 4, which is the axis of symmetry. So if you were to draw a graph, probably it might look something like this. Okay. Maybe I'm just going to redraw this little bit here. And we have x equal to 4, which is somewhere here. Okay, so this is -1, 9, this will be 0, -9. So this is just a sketch of the graph. And we're supposed to find the values of a, b, and c. Now, we don't really have a lot of information except for the equation of the symmetry, which is x equal to 4. And so technically, if we can't use the calculator to solve questions like this, then I guess the best techniques to solve this question is to think about what are some of the formulas we know about quadratic graphs. And we know that the axis of symmetry, the formula to find the axis of symmetry is x equal to -b over 2a. So we could practically try to use formulas that we are familiar with, and maybe we could come up with something concrete that will help us to solve the question. Now, we know that the axis of symmetry is x equal to 4, so I'm going to substitute x to be 4, and I'm going to have 4 equal to -b over 2a. And if we try to simplify this equation further by multiplying by 2a on both sides, you're going to get 8a equal to -b. All right, and so b generally could be written as -8a. Now, that would be my first equation that I have, okay? So we know that there is a relationship between a and b. Now, we do have 2 points, which is 0, -9, and -1, 9. What I will do is, theoretically, since the points are on the graph, then it will make sense to substitute these 2 points into this equation. So what I'm going to do is I'm going to sub 0 and -9 into the equation. So I'm going to get something like this. Since y would be -9, this will be a multiplied by 0 squared plus b times 0 plus c. Now you realize that this turns out to be 0. So I'm just going to end up with just c, which is -9. So I just got the value of c, which is great. And I'm going to do the same thing for -1 and 9. So I'll do 9 equal to a -1 squared plus b -1 plus c. So I'm going to get something like this, which is -1 squared will be just 1. So this will be a minus b. And since c is -9, I got this. Okay, and I'm just going to put all the numbers on one side of the equation by adding 9 on both sides. So I'm going to get something like this, which is a minus b. Now, I got this equation here, and I have this equation here. All right, and since I have 2 equations with 2 unknowns, I should be able to find out what my a and b is. Okay, so all right, so I'm going to quickly show you how we can do this. I'm just going to erase the graph here. And I'm just going to quickly show you how we can solve this equation. All right, so since b is -8a, what I could do is I could replace this b with -8a. So I could rewrite it like this, which is 18 equal to a minus -8a. And if I simplify this on the right side, I'm going to get a plus 8a. So I'm going to get 9a, which gives me 18. So a would just be 18 divided by 9, which gives me 2. So I just got the value of a as well. Now that leaves me with just simply finding b, which obviously I could make use of this equation. So I could find b by taking b equal to negative 8 times 2, which is negative 16. So I just found my a, I found my b, and I found my c. Okay, so I just thought I would like to illustrate this question just to show you that sometimes we do need to consider using some algebraic approach. I know this is not great for AI students, but please bear in mind that it really depends on what kind of information is given to us in the question as well. All right, so I just want you to be aware that a scenario like this could happen. Okay, so hopefully this gives you another perspective on how quadratic graphs could look like with the equation of the symmetry. Okay, now I'm not going to go through some of these questions because they are quite repetitive. What I really want to do is to spend a bit of time on problem solving, which is quite a big thing, particularly with the AI papers. Again, this video is meant for more primarily for the AI students, but yes, the AA students are able to get quite a lot from this video as well, because a lot of these questions could come more on an using an algebraic approach to solve these questions. Okay, but I just want to show you one example that I found from the Oxford textbook that actually could be quite a nice question to spend some time on, which is basically this question. I'm going to look at question 3, which is about Omar in the school shot put team. So what they did was they gave you an equation of the quadratic function. They basically define what y is, which is the height of the shot put in meters, and x is the horizontal distance traveled in meters. Okay, so the question is asking, find the maximum height that the shot put reaches. Okay, now technically if you were to draw a graph, all right, and we're going to call this y, we're going to call this x. So technically if you were to model the path of the shot put, it should somewhat start at a certain height, because when you throw the shot put, it should come about the height of the person who is throwing it. So it should somehow start from somewhere along this at a certain distance on the y-axis. Then it's going to go up, just because then it's going to go against gravity. Then it's going to start coming down somewhere about here. Right. So it will probably look something like this. Okay. So we do want to find out what is the maximum height that the shot put reaches. Okay. So we have this function here, which is 1.5 plus 0.75x minus 0.05x squared. So what we're going to do is we're going to try to attempt this question. Okay. So yes, I'm going to keep this. What I would do is, let me just insert a new slide because I need some space. Let's cut this out. Let's cut this out as well. Okay, so all right. So I'm going to put this equation 1.5 just give me a while. Put this here. So we're going to have y equal to 1.5 plus 0.75x minus 0.05x squared. Okay, so we're trying to find out what is the maximum height of the shot put. Okay, So earlier we drew a graph that looks something like this. So it's going to go up something like this, and it comes right all the way down. So we're trying to find out what is this point here. Okay, so we got a few ways. If this was an AI paper, then you could literally just plot this graph onto your GDC. So I'm going to quickly show you how this works. So let's go to the calculator. We're going to go and plot this. Let's clear this first. So you're going to get 1.5 plus 0.75x minus 0.05x squared. Okay, and I'm going to graph it. All right, then what we're going to do is we're going to go to second trace. We're going to go to maximum. Okay, so the maximum somewhere is going to be about here. So put the left bound somewhere here, and the right bound should be somewhere about here. Okay, and we got the maximum point to be 7.5 for x, and y to be 4.3125. Okay, and since we're looking for the maximum height, we should be looking at the y value. So we're going to be taking 4.3125. Okay, so maximum height will be 4.3125 meters. Now, if you're going to do this without the graphing it, you could find out what is first the axis of symmetry, which you obviously could do it by doing x equal to minus b over 2a. So x would be equal to the coefficient of x, which would be the value of b. So it would be negative 0.75 divided by 2 times the coefficient of a, which is negative 0.05. Okay, and you could just work this out. This is 0.1. So if you work this out, this should give me 7.5. Okay, so which means the x value is 7.5. Now, in other words, if you want to find the y value, you could just substitute this value into the equation, and you subtract 0.05, 7.5 squared. And really all you need to do is to put this onto your calculator, and you should get the same answer as 4.3125. Pros and cons, I think AA would definitely prefer the second way if it's a paper 1 question. The AI students would definitely prefer just graphing it and finding the maximum point. Okay, but I just want to show both ways. Now, so part B, it asks for the equation of the axis of symmetry. Okay, and that's a good question because we just literally found it, which was this, which was just simply x equal to 7.5. Okay, so that would be the equation of the axis of symmetry. So this formula is really, really important. But the good thing is that for those who are in the AI course, if you found the maximum point, which happens to be 7.5, you could literally just have taken this from the graph as well. As long you wrote this as x equal to 7.5. Please do not write the equation of axis of symmetry to just be 7.5. This would be wrong because this is not an equation. You need to write x equal to 7.5 for the equation of the symmetry. Okay? Now part C, it says find the positive value for x when the graph crosses the x-axis. So we're trying to find out this point here. What does this number actually tell us? So before we do that, let's go find out what this value is first, okay? And simply, we can just go back to the calculator. We can go to second trace. We can go to 0. But since the graph did not show the x-intercept, now we're not going to look at the negative portion because you can't have a negative distance, horizontal distance. So we need to change the window size for this. I'm going to change my window size. Maybe I'm going to change my x maximum to be 20. Okay, let me just delete this. I'm going to put 20 for now, and I'll graph it again. All right, so I should be able to see the positive x-intercept. Then I'll go to second trace again. I'll choose 0.
Download Monopoly Go and play the new Star Wars event today.
This really annoys me. Okay, so sorry about that. So let's go back to second trace. I'm going to choose option 2, which is 0. Left bound, you want to choose this, and right bound, let's move to the right of the x-intercept. This will be good. So you're going to get your 0 to be 16.78. I'm going to round it to 3 as F will be 16.8. Okay, so the x-intercept, all right, will be 16.8. And the question is asking, what does this value actually represent? So what does this value represent in this context? So we could say that this 16.8 is the horizontal distance the shot put has traveled before landing on the ground. Oh, sorry, should be has traveled. Oh no. Okay, I'm just gonna rewrite this again. So horizontal distance, the shot put has traveled before landing. Okay, so I think that would generally explain what 16.8 means. Now let's bring on to the last bit, which is part D, which is asking what this value represent, which is the y-intercept. Now the y-intercept is basically when x is 0, and we could easily substitute this number into the equation. So you're going to get 1.5 plus 0.75 times 0 minus 0.05 times 0 squared. So you're going to be left with just simply 1.5, because this is going to be 0, this is going to be 0 as well. So this kind of makes sense, because it means that the shot put was being thrown at initially at the height of 1.5 meters. Okay, so that's what it means. So this 1.5 basically means the height at which the shot put was thrown initially. Okay, so again, I just thought I want to show you a question that requires you to use all these little concepts that allows you to apply the formula of the axis of symmetry, understanding how the x and the y intercepts work, being able to sketch the graph based on the scenario given, being able to use your GDC if you're allowed to have access to it, to find some of the key points on the graph, and that generally would be some of the very common questions that you probably would see with quadratic functions, especially particularly, like I said, for the AI students. While the AA students, you may have to deal with this without the calculator as well, which means that besides knowing how to do axis of symmetry, you will be expected to know how to solve quadratic equations, being able to find things like the x-intercepts, even without the use of the calculators as well. All right, which means, like I said, being able to solve quadratic equations, which I will probably do it in another video. But I hope this helps. I will look at some different types of IB questions that relates to quadratic functions. But I hope this video gives you or allows me to show you how we could apply the use of quadratic functions into real life problems. And hopefully this video helps. So if you like this video, please, as always, like my videos, subscribe to my channel, and give me some, if you have anything that you would like me to solve, please, all right, just drop me a comment. And I do read those comments as well. All right, so thank you very much guys for watching this video, and I'll see you very soon.